A new era of military small arms. The U.S. Armed Forces have made a deliberate and strategic move, not a cosmetic tweak, but a purposeful redefinition of what a modern infantry cartridge must accomplish. This decision to field the 6.8 by 51mm, the civilian equivalent often marketed as 277 Sig Fury, follows a clear line of reasoning. Battlefield realities and adversary capabilities have changed, and the doctrine that once favored light, high-volume fire must adapt. The cartridge was engineered around roughly 140-grain projectiles, and certain loadings deliver muzzle energies in the neighborhood of 3,000 foot-pounds. Those figures are not just numbers on a spec sheet. They translate into fundamentally different terminal effects and engagement geometry. To unlock that performance, manufacturers moved past conventional case metallurgy and pressure norms. The 6.8 by 51 works at very high chamber pressures, and to tolerate that reliably, it uses a hybrid case design, a steel head bonded or mechanically joined to a brass body. The steel head preserves structural integrity under extreme stress. The brass body preserves extraction reliability and ductility. It's an engineered compromise that lets the cartridge push far more energy while avoiding catastrophic case failures in the field. That design decision is central to the cartridge's identity and to how weapons and support systems must be built around it. The significance of this change reaches beyond ballistics tables. When you shift a service's basic ammunition type, you change training, maintenance, logistics, vehicle payloads, and even the psychology of troops in contact. That's why the move is framed not as, "we changed a round," but as, "we changed how infantry fight." The 6.8 by 51 is a technical answer to tactical questions: how to reach farther, penetrate better, and win decisive engagements with fewer rounds and less exposure. Ballistic power, range, and tactical necessity. Ballistics is where doctrine meets outcomes. Traditional 5.56 loads begin to lose meaningful terminal performance after a few hundred meters. Beyond that point, the probability that a single hit will stop a protected threat drops substantially. The 6.8 by 51 changes that curve. In routine loadings, it retains supersonic velocity and useful terminal energy well past 600 meters, enabling realistic one- or two-shot outcomes against targets protected by modern body armor or behind light cover. For small units, this alters the entire engagement calculus. A contact spotted at distance is no longer automatically a suppression and maneuver problem. Instead, trained shooters can engage with aimed fire that is likely to be decisive. This change is not academic. After-action reports and field feedback have shown scenarios in which 5.56 discharged volleys failed to stop armored adversaries quickly, requiring many hits or risky close maneuvers. That's costly in time, ammo, and exposure. The new doctrine emphasizes overmatch, which means outranging and outpenetrating the enemy so that initiative and decisive action rest with friendly forces. Overmatch requires accurate ballistics, reliable weapons, and a mindset that values precision over raw volume. Yes, there are trade-offs. Each 6.8 by 51 round is heavier and produces a stronger recoil impulse. Soldiers carry fewer rounds by count, and logistics must adapt to greater weight per round and different storage/transport considerations. Commanders have weighed these trade-offs and concluded that fewer, more effective shots are tactically superior to many rounds that might not stop a plated adversary. That shift affects everything from how ammo is apportioned on patrols to how vehicles and helicopters plan resupply. Weapons, optics, and training for a new doctrine. It's not enough to create a more powerful round, you must also build the tools that allow soldiers to use it effectively. New weapon families were developed with this cartridge in mind, not as retrofits. The M7 rifle, for example, uses a short-stroke gas piston system to better manage fouling and cycling stresses in a high-pressure environment. Many configurations ship with integrated suppressors to reduce muzzle flash and improve control, two practical benefits that make follow-up shots and squad stealth more effective. On the automatic weapons side, belt-fed systems like the M250 were engineered to deliver sustained, accurate fire at extended ranges while incorporating recoil mitigation features so that the weapon remains a precision support tool rather than merely a sustainment of fire platform. Crucially, the weapons are paired with modern fire control optics and sensors. Compact units like the XM157 fold laser rangefinding, ballistic solvers, and environmental sensors into one device, providing the shooter an instant holdover or correction. That integration converts raw ballistic capability into consistent battlefield results. When an optic gives a shooter a corrected aim point, accounting for range, wind, and temperature, the probability of a first-round hit at distance climbs steeply. That leads to a different training regime. Live fire ranges must be extended, drills reworked for aimed fire at distance, and shooters trained to interpret and trust digital ballistic solutions in high-stress conditions. Soldiers become operators of integrated systems. They learn to manage optics, sensors, and data alongside marksmanship fundamentals. Training also addresses recoil and weapon handling. Shooting heavier rounds repeatedly requires different recoil mitigation techniques, different follow-up shot drills, and a focus on ergonomics. The human-machine interface becomes as important as ballistics. A well-trained operator with a modern optic and a rifle built around the cartridge can achieve far higher hit probabilities than an untrained shooter trying to compensate with volume fire. Civilian market, costs, and global implications. When the military pivots, civilian markets notice. The commercial counterpart, 277 Sig Fury, is already present in bolt guns, a limited number of semi-autos, and precision platforms. For hunters, the cartridge offers flat trajectories, strong retained energy at extreme ranges, and bullet construction options that make ethical long-range takes on elk, moose, and large bore realistic. Precision competitors see a cartridge that bridges conventional .308 energies and magnum performance, offering a new performance window without the same recoil or barrel wear of bigger magnums. Still, practical barriers exist. The hybrid case is more complex and more costly to produce than traditional drawn brass, and that translates to premium retail prices early in the adoption cycle. Reloaders face learning curves. The steel head changes resizing dynamics, case life, and requires adapted dies and procedures. The aftermarket will respond, but it takes time and scale to drive down cost. On the strategic and allied level, the adoption raises interoperability questions. NATO's logistical efficiency historically depended on shared calibers and magazine compatibility. Introducing a high-pressure hybrid case round forces allied nations to choose between continued commonality and investing in new capability at the cost of logistical complexity. Scaling hybrid case production and integrating it into allied supply chains would require industrial investment and political willingness to accept short-term friction for long-term gain. There's another potential upside. If hybrid case tech proves economical at scale, it could be applied to other calibers and open new design avenues, offering higher pressure ceilings and tighter ballistic performance across a range of cartridge families. That could be transformative, but only if the industrial base can produce at price points acceptable for sustained military and civilian demand. The future of infantry combat. Taken together, the adoption of the 6.8 by 51 is a turning point that touches tactics, training, logistics, industry, and soldier psychology. Tactically, squads gain reach and the possibility to end contacts quicker with fewer rounds. That reduces exposure and can make missions more efficient and less wasteful of resources. Psychologically, troops who trust their kit's ability to penetrate modern protection at range act with more initiative and confidence. That intangible effect translates into measurable combat advantages. Logistically, planners must adapt to heavier rounds and different resupply profiles. Cost becomes a planning parameter. Strategically, allies must evaluate whether to follow, adapt, or retain legacy standards. Technologically, hybrid case engineering could be the springboard to broader changes in ammunition design, unlocking pressure regimes and ballistic performance previously constrained by metallurgy. Is the 6.8 x 51 the ultimate answer for infantry small arms? Maybe, maybe not. It is clearly a deliberate, data-driven step toward regaining overmatch against current threats. Whether it remains a dominant standard or becomes a stepping stone toward even more advanced concepts depends on operational experience, manufacturing scalability, and allied choices. For civilians and enthusiasts, the coming months and years will reveal whether platform diversity, production scale, and hand-loading practice mature to the point where the cartridge becomes commonplace, or whether it remains a high-performance niche.